Hi students, let us learn about magnetic field due to a current through a circular loop. In our previous class, we learned about the magnetic field due to the current through a straight conductor. Let this be a straight conductor and the magnetic field around that straight conductor will be in the form of concentric circles. The strength of this magnetic field increases as the current passing through the conductor increases. Also, the strength will decrease as the distance from the conductor increases. The magnetic field strength is directly proportional to the magnitude of the current and inversely proportional to the distance from the conductor. Now, we are going to bend the straight conductor into a circular loop as shown in this diagram. Now pass an electric current through this circular loop. Electric current flows from the positive terminal to the negative terminal. When electric current passes through the coil, magnetic field will be produced around that coil. The direction of these magnetic field lines can be found using the right hand thumb rule, which we learned in our previous class. If you reverse the connection, instead of positive, give negative terminal here, and instead of negative, give positive terminal here. In that case, the electric current starts flowing in the opposite direction. When electric current is reversed, the magnetic field also reverses its direction. Also, the strength of the magnetic field depends on the number of turns of the coil. If current increases, the magnetic field also increases. If direction of the current is reversed, magnetic field will also be reversed. If the number of turns of the coil increases, the magnetic field increases. Let us connect a battery to this circular coil, such that the positive terminal of the battery is this side and negative terminal on this side. The electric current starts flowing from the positive terminal of the battery to the negative terminal of the battery. The electric current is flowing in this direction. When the electric current flows in the circular coil, magnetic field is produced in the coil. In this section of the electric coil, the electric current is flowing in this direction. Whereas when you consider this section of the coil, the electric current is flowing in this direction. To draw the magnetic field lines, we can use the right hand thumb rule. Hold the coil such that the thumb points the direction of the electric current. When you consider this part, this is the direction of the electric current flow. The curled fingers will give you the direction of the magnetic field. This will be the direction of the magnetic field. When you consider this part, the electric current is flowing in this direction. Therefore, the thumb should point in that direction. The curled fingers will give you the direction of the magnetic field. The magnetic field will be like this. Please note that the direction of this magnetic field lines inside this loop is in the same direction. You can use the right hand thumb rule to find out the direction of the magnetic field. To observe this magnetic field lines, you take a rectangular piece of cardboard having two holes and insert this coil through these holes. Connect the ends of the coil to a battery and a key as shown in the diagram. This is the battery and this is the key. The ends of the coil are connected to this battery and key. This is the rectangular piece of cardboard. You sprinkle some iron filings on this cardboard. When electric current passes through this coil, when the key is closed, electric current starts flowing in the circuit. When electric current starts flowing in the coil, magnetic field is produced around that coil. You observe the iron filings by gently tapping this cardboard. These iron filings will arrange themselves in the pattern as shown in the diagram. As the distance from the coil increases, the magnetic field strength decreases. You can see at the center of the circular loop, the magnetic field line is straight. If you move away from the center of the loop, the magnetic field lines are diverging. Inside the circular loop, please note the field lines are having the same direction inside the loop. Let us summarize what we learned in this section. The magnetic field strength is directly proportional to the magnitude of current. It is inversely proportional to the distance. By right hand thumb rule, the magnetic field lines are in the same direction within the loop. The magnetic field lines appears straight at the center of the loop. On moving away from the center of the loop, the magnetic field lines keep on diverging. If you have a circular coil of n turns, then the field produced is n times as large as that produced by a single turn. This is because the current in each circular turn has the same direction, and hence the field due to each turn just adds up. Hope you understood this session. We'll see you in the next class.